Hi, everybody. It's day 3. I've been trapped in this classroom for 3 days. The air outside is poisonous. I've subsided on nothing but counting beans and a spendthrift. Oh, there's this sound, though. Ah! Who is this? Oh my gosh, I knew it. Oh my gosh. It's topic 12. Wait a second. Topic 12? How did you find me here? Oh no. Wait a second, everybody. Ah! Stay. Good, topic 12. Ah! Look. Don't worry, kids. I know everything about topic 12. It is a little bit noisy and it is a long chapter, but together you and I can do this. Okay? Let's go out and I'll introduce topic 12 to you. It's all about fractions. Okay? Come on, topic 12. Ah! I think I tamed it. Oh, there he goes. Catch him in a moment. Okay. Topic 12, I'm coming. Don't worry. I've been hiding here for a while. But now I know that sound was just a little topic 12. Okay, so what are you going to learn in this chapter? Well, it's now going to introduce the big idea of adding and subtracting fractions and kind of cool stuff with like unlike denominators and mixed numbers and even improper fractions. Here, let's set up over here. I seem to be ready. Hold on a moment. I'm going to turn on the classroom lights. Okay. It's a little dark in here. Oh dear. Somehow we have 22 linked iPads in the back of the classroom, all calling each other. I don't know. All right, so big idea. Topic 12, since you just finished topic 11, that was the introductory chapter 2 fractions. This is a continued understanding of fractional use. So the first 2 lessons, and I've grouped them this way for a reason. So you're going to be doing, on Monday, you're going to do 12.1 and 12.2, and then on Tuesday you're going to do 12.3 and 12.4. Now it seems like a lot to do 4 lessons in 2 days, but they're so closely related, and they make so much sense when taught together. I think you're going to find it fun. I also I also have for you this week as an attachment, if you go in and look, it's called Tool 15. So Tool 15, these are the fraction bars I've often talked about. I thought maybe if you want them, you just print them off. You can use them, cut them apart. You can print multiple copies if you still like them, but they're back there for you to use. Now, let's talk about the model. When you hear anything about the model, usually it's going to talk about fraction bars or the number line. And if you hear just adding or subtracting fractions with like numbers, it means it's the algorithm. And this is a really easy algorithm to remember. The models, when you put them together, it makes more sense. So let's start. So you're going to be working, I'm so glad we figured out it was only chapter 12 in here when I was alone, just running around. Just needed to be, caught by you. Aren't those strange? We've got a melody of iPads in the back doing this funny thing. Okay, so let's begin with the big idea. Sorry. Kind of was prepared on that side. So you have, today's lesson is to work with fraction strips so that you can see what it's like to add things up. So the first question I have for you comes from 11 to 12, 12.1. So I want you to do a couple things in this chapter if you need it. Use the models. And that's teaching tool 15. And you have this available to you, just print it off at home, okay? And there's going to be, on Wednesday, you're gonna have a number line lesson, so I'll make sure you have that as well. Okay, let's get into it. Hopefully glue is okay. I decided to use our big white paper today. So let's talk about ways to model a fraction. So they give us an example and they say, what are ways to model 3/5? Okay, we talked about 5 as being that tough one to model, so the denominator here being 5. So what are some ways that you can model 3/5? Does it always have to be a bar? Okay, so what you can do, you can get, okay, well, I'm gonna draw a bar because fraction bars are the easiest things to deal with, right? And 3/5, again, those fifths are tough. Let's see if I can do it. Oh boy, whew, that was close. So these equal 1/5 each. And if we had a total of 5 of them, we have 1 whole. So let's make sure I'm right. 1, 2, 3, 4, 5. So we have 5/5. So what are some ways to model 3/5? I'm gonna use a different color. Look, I have these really cool Sharpie flip chart boards. So we can say 1, 2, 3. Okay, so that's what 3/5 looks like. I want you to keep in mind that benchmark fraction we talked about last week. Is this bigger than the benchmark fraction of 1/2? Well, what's kind of cool, just to keep this in mind, on the fraction bars, they're all going to be pretty easy because they're all made for you. So this is going to be 1/2, and this is 1/2. You can kind of see that 3/5 is larger than 1/2 using that benchmark fraction. As compared to a whole, this week you're going to be introduced to the whole bar, which looks like this, and it's just called 1. And then you're going to be comparing it to 1 as well. So you can see it's not quite 1 whole, obviously, because there's only 3 of the 5 that are filled up. Okay, so another way to model 3/5, you might think, okay, well, let's do a pie graph. So I would start with this, try to do this. It's a little bit trickier than you think to do 5 in a circle. They would give me this challenge to start off with. Let's see if I've done it. So 1, 2, 3, 4, 5. Whew. So this is comparably 1/5, 1/5, 1/5, 1/5, and 1/5. So on the pie graph, this would look like 3/5 would look like this. So again, and you see in a visual sense, it's big. It's bigger than 1/2, obviously. So those are some ways to model what it looks like. For the sake of what we're doing this week, we're going to use regular bar models, or I'm going to call them fraction strips. Okay. Ooh, going through this really nice sticky note paper like water. A little dangerous. Okay. Sorry, still working here on my makeshift floor. So when you have the fraction strips, I mentioned to you that you're going to be using a whole bar. So I'm going to replicate this up here. So everything's going to be compared to 1 whole. I'll try to keep the same length. So there's 1 whole. And you're going to also keep in mind this too. This is our famous benchmark fraction of 1/2. Okay, so hopefully, now when you're doing these by hand, you don't always get it even. So keep that in mind. These are the 2 kind of comparative bars you're going to use. So in today's lesson, it says, Megan is working on a community mural. She paints 3/8 of her wall green and 4/8 purple. How much of the wall has she painted so far? So if you've printed out those fraction strips, I want you to use the 1/8 strip right down here. But I'm going to replicate it on a bigger scale. I'm going to keep these 2 up here so you can kind of see, and I'll try to keep them the same size too. So again, back to the question. So we have to have these 8s. So try to keep it the same size. If you hand draw these, it's fine too. Oops. There we know we're dealing with 8s, and 2 is a factor of 8. So I'm going to go ahead and get both of these divided up fairly. Okay. So we've got 8s. So we start with quarters, and then in half again. Okay, I connected 2 bars together, just so you know. And I'm going to try to use some colors that they said. So the lesson basically says find some colors to use. So Megan again is working on a community mural. She paints 3/8 of her wall green. So let's use this. We'll say this is these are all 1/8. So we'll go 1/8, 1/8, and 1/8. So this part is going to be green. Okay, and then technically we could have just added on to this, but I want to show you what it kind of looks like. And then she painted 4/8 of her wall purple. So we have 1/8, 1/8, 1/8, 1/8, 1/8. So all of this is purple. Now if we were to combine them, which is the cool thing, I guess I'll take the bottom, and I'll just, since this is longer, I'll add my 8s here. So there's another 8th, another 8th, and another 8th. So what we've done is kind of combine them. So we did 3/8 plus 4/8. And you know another name for 4/8. Oh, look, 1/2, right? So this is pretty easy. It's the algorithm. It's actually better to use them when they're all lined up and neat and tidy. In this case, I got a little high here, but 4 plus 3, that's right, 7. And we keep the denominator the same, 8. So you can see up here, the answer, she painted 7/8 of her walls with color. And here's the bar to model what it looks like. You can see that there's 1/8 left she didn't paint. Maybe Megan is gonna paint it a totally different color. So far she's painted her wall with 7/8 color. Okay? So you're gonna be diving into chapter 1. It's gonna look pretty much like algorithm after this, so you can kind of see that's the model. Okay. I'll switch back to blue. So if we go to the guided practice, the first question that they give us, it says, in 1 through 6, use fraction strips, add fractions, simplify if possible. That key word, simplify, oops, that's simply, simplify, oh boy, simplify if possible. So that means down to prime. And we talked about that last week, okay, down to prime. So if we did 1/3 plus 1/3, what does that equal? 1 plus 1, yeah, 2. Keep the denominator the same, 3. Is that one whole? No. Okay, let's do number 2. I didn't mean to do that. Number 2 is 1/6 plus 1/6. Forget that line. What do we have there? 1 plus 1, yep, 2, 6. Wait a second, can we leave this? No. Why? I'm seeing something that they might have in common. 2 is a factor of 6, and I know we can divide to simplify, and that's really what you do when you simplify. You're dividing by that same factor. Say, okay, I'm going to take a 2 out of each one of those. So to simplify, another name for this would be 1/3. And how does that look on a fraction strip? I'll draw it down here since I've already got a line kind of started. So we have, I'll draw 2 again. 2 fraction strips. Oh gosh. I'm going to start with, since we're doing thirds or 6s, I'm going to go ahead and divide this by thirds. And I'll do the bottom. Oops, not quite even. So we have 1/3, 1/3, 1/3. And in the bottom, since we're dealing with 6s, now I'm going to take each one of these boxes and divide it again by 2. So now we have 6. And not quite even, sorry about that. So we have 1/6 and 1/6. So if you said the answer was 2/6, so here's 2/6, you can see right up above, here it is, it's also equal to 1/3. Not kind of cool? So it is simplifying, meaning you're bringing it down to prime. This can't go any further. It's done. Okay. Lesson 12.2 is so easy. It's just like this, but now not using the model, and it's just going straight into the algorithm. So let me grab the paper real quick. Okay. So if we had this, and the purpose of this lesson is basically to add fractions with like denominators using this standard algorithm. So it's pretty basic. Here is an example for you. It says, it's using the example, so we're looking at 12.2 for you guys. Again, why I grouped them is because they're very similar. Okay. 2/5 plus 1/5. Okay. Same lesson. What do we do with first? What do we start with first? Right, the denominators. The numerators. I like that, numerators. 2 plus 1, 3. What do we do here down here? Continue the same. Okay. What can we do? Is it to be simplified? Are 3 and 5 a factor of one another? Nope. So it's at what we call simple prime. It's done. It's simplified. Can't do it anymore. So what is the denominator of this sum? Do you see it? The sum meaning, yes, we are adding. So the denominator is going to be 5. Okay. And then it says, how do you decide? Well, you look at the bottom. Over and over in the last chapter, I told you that the denominator is the most important. In this case, it still is the most important. It tells you what's going to be represented over. And then, of course, how do you find the numerator? You add the tops together. It becomes a different story when you get into unlike denominators, and we haven't quite got that far yet, but this is a good start. Let's do an example. So again, following the lesson, if we did, this is the GP, okay? GP says, on number 1, 2/4 plus 1/4, okay? What does that equal? 2 plus 1. Yep, 3. And then we carry the 4 over. Easy enough. I want to bring you to something that's maybe a little bit trickier. Number 2, I like this one. It's 1/3 plus 2/3. And you might be going, wait a second, something's different about this one. 1 plus 2. That's right, 3. Denominator is also 3. What's another name for 3 over 3? 1 whole. That's another name for it. So again, that's the lesson today. So 12.1 and 12.2 are very similar. One's just using the models. So you can print this off and you could use this to add with if you'd like. Or you could go straight into the algorithm. Tomorrow we'll loop up and we'll do another 2 lessons, but it's going to be subtracting. So just the opposite of this. Thanks, you guys. I don't know. No! No, it's back! No, chapter 12! Well, at least I'm not alone anymore.